this top part is just recalling information we already said. We said a chord is a segment whose endpoints are on the circle. So this right here is a chord, but more specifically right here would be our diameter. But it's a diameter and a chord. That's why it's special. It's a diameter. It's diameter and a chord. All right, so that means a diameter is a chord that goes to the center of the circle and divides the circle into two semicircles, which is a 180-degree arc. All other chords divide the circle into either a minor arc or a major arc, which is listed over there. Major arc is going to be one that's greater than 180, so this major arc would be right here. We would label this major arc with 3 letters, so I'd call something like A, C, B. The minor arc is less than 180 and it'd be marked with just 2 letters. Call it A, B. So a minor chord arc is always 2. A major or semicircle is always going to be 3 letters of markings. All right, so we said a diameter cuts our circle at 180 degrees, right? So this angle right here is 180 degrees. How many degrees are in a circle? 360. So how many degrees would this arc be? Yeah, it'd be 180, which leads us to our next point with central angle properties. The main property of a central angle is the measure of an arc is equal to the central angle, or the measure of the center angle. So if we look at this one, we have a center angle GE, or EGF, I should say in the proper order. It makes it a central angle because G is the center of the circle. Remember, a central angle always goes to the center of the circle. Well, if that angle is 65 degrees, that means the measure of the arc, EF, is going to also be 65 degrees. So that means the measure of the arc, so the measure of EF, that's a squiggly, equals 65 degrees. What other arc do I know the measure of then? Amber?
The major arc, EGF, or what would you call that one?
We'd have to name something, yeah. So we'd have to pick a point, right? Because it wouldn't be quite G, because G isn't on the circle, so you could pick any. What letter is your favorite letter?
W.
Ugh. All right, W. So we'll call it UF. And what would the measure of arc UF be? Did you already say it to me? Did you give me it?
It's 360 minus 65, which is 295.
295, yeah. So knowing this center angle, I know this minor arc, and I also know this major arc because it equals 360. So our central angle is always going to equal that arc that it cuts out. All right, so quick example. Find the missing angle or arc. So if you look, we have a little question mark right there. It's not going to take a whole bunch of work. Can someone tell me what that little question mark equals? It's going to be a degree. Akshay? It's going to be 120 degrees. Because if the measure of the central angle equals the arc it cuts, if I know the arc it cuts, I also know the measure of that angle. All right, our next one's a little more difficult. I'm supposed to find the measure of F to D. So that would be from here all the way to here. I need to find that measure. Well, let's break this down. So I see that we have an 81 degrees and I have a 135. Do not forget about vertical angles. So notice that 135. That 135 is a vertical angle to this angle right here. Do we all see that 135 and this 135 being vertical angles? Do we all picture that, or are we just quiet and we're just working on it? All right, so these must be vertical angle. So that whole measure equals 135. Not terribly important, but it's slightly important because our other two vertical angles would be B, whatever our center is, C. Let me do it in red. And this angle here. How do I get those measures of those missing angles? Yeah.
Well, you would subtract 180 minus 135.
Mm-hmm.
Because like FC and EB are both like diameter. So then you get 45.
Yeah, sure. So we can do 180 minus that 135, which gives us 45 degrees. And that 45 degrees is just going to be here, and our 45 is going to be here. So then it says we are supposed to find from F to D. So F to D is just going to be 45 plus 81, right? And Evan, what did you come up with? 126 degrees. Did we all get 126 degrees? Make sense? Some of these are kind of like puzzles. They're puzzles where you have to look at vertical angles, see what stuff you can subtract. Like we could have went further. We could have found this measure because we could have did 135 minus 81. Sometimes we have to find this one. It's kind of like a puzzle that we have to put together. All right, the next thing we're talking about are inscribed angles. So a central angle, our central angle is the same thing as the arc that it cuts. Our, did I just go to the examples? I think I'm missing a slide. Can I see your sheet? There, all right, so where our central angle was the exact same, our inscribed angle, so the measure of the arc is twice the measure of the inscribed angle. So if our inscribed angle is 34 degrees, the arc it cuts is going to be 2 times that 34 degrees, which is going to equal 68 degrees. Yes?
Can you say it's equal, like for the... Oh, that's central.
That's a central angle. Yeah, we got to be very careful where it ends. If it ends in the middle, it's going to be the exact same. But if I picture this, right? A center angle, let's draw a center angle on top of this just to kind of get an idea. See how this angle is bigger? And it has to get smaller to reach further back. So the further back you go, the smaller it's got to get. The closer it goes, the bigger it is. So a central angle right here would actually be 68 degrees. But the inscribed angle is 34, which means the arc it cuts is going to be 68 degrees. All right, let's put that in action. It says find the missing angles or arcs. Can someone tell me what that missing angle is? So that would be the measure of angle, let's call it cab. Aiden? 40. It's going to be 40, yep. It's going to be half of that 180, which equals 40. I'm just going to put half of that 80, which equals 40 degrees. Perfect. Our next one's a little trickier. We got to kind of put this piece together. So we're trying to find that missing that P to D. So this is how we're going to do it. This 35 degrees is this inscribed angle here. So that inscribed angle here is going to be 35 degrees. I'm sorry, it's going to be 70 degrees. Thank you, good catch. But the thing that's missed most on any one of these projects is our semicircle. And that is the fact that from F, P, D, that's a semicircle, so that needs to be 180 degrees. So that question mark is just going to equal 180 minus that 70, which equals 110 degrees. There's other ways to solve this one, but this is probably the easiest one. Questions on that one? Yeah.
So could we say that like the inscribed angle of D also equals 35, like the bottom half of it? Like F DP.
F, say that again, F, D.
DP. So like the angle is
Yes, yes. Yes, we can absolutely say that. Yep. So what Evan just pointed out was, since this is 70, I could have also asked you for angle EFP, because that would be 35, because that's also an inscribed angle where the arc it cuts is 70 degrees. So that's where it's kind of like that puzzle that I was talking about, that I might have you go from here to here, that you need to put it together. All right, those aren't too bad. Those are pretty easy as long as you know you have a central angle or an inscribed angle. These get a little trickier. Maybe not the first one. So it says two minor arcs are congruent if and only if their corresponding chords are congruent. So what that means is, say that chord AB is equal to CD. That means the two arcs would also be congruent. So as long as I knew that AB and chord CD were the same, I can say that the arcs are also the same. And where that kind of comes from is, if I wanted to, you don't need to write this down, but if I drew an inscribed angle on here, that'd be the same measure as an inscribed angle here, just because they go to the same arc. But if two chords are the same length, the arc they cut is also the same. The other two are huge ones. That one's nice, it's good to know, but the other two are going to be really big ones. So the first one says the perpendicular bisector of a chord is a diameter or radius of the circle. Once again, the perpendicular bisector of a chord is a diameter or a radius of the circle. So we read here, if QS is a perpendicular bisector of TR, then QS is a diameter of a circle. What's key here? What's key here is not memorizing all of that stuff. What you're looking for, what you're honestly looking for in these problems, is you're looking for that 90-degree symbol. That 90-degree symbol, along with a central point, is going to tell you that it's bisecting that chord. So a 90-degree angle and a central point is going to tell you it's bisecting. It is actually bisecting. And so I kind of put this bone in. If a segment from the center of a circle is perpendicular to a chord, then the segments bisect the chord. This is the big sentence out of all that I'm saying. This is the big one. This is what it's going to look like on the homework. It's what it's going to look like on the test. I'm going to give you something that looks like this, and I will not give you these are congruent, and you just have to know they're congruent because it's perpendicular and it goes to the center. So this right here is really important. In fact, before I even start the next thing, let's think about this. I'm just going to apply this to the next bottom one. So if this is true, if we look down here, we have the 90-degree angle symbol. It's going to the center. So based upon what we just did, I also know that CG is congruent to GD. And I know AF is congruent to FB, but I'm not going to make that mark just yet. Bless you. But if I was to put that down, we automatically know that. But let's read the second point. The second point says two chords are congruent if and only if they are equidistant from the center. Once again, two chords are congruent if and only if they are equidistant from the center. And how that's going to look here. It's going to look something like, well, let's say that G and E are congruent. Let me pick a different color. Let's let G and E equal E and F. These are distances. These are distances. And right now I'm saying CD is the same distance away from the center as AB. Do we see that? Since they are the same distance, that means AB is congruent to CD. And that's because EF is congruent to GF. So putting both of these two things together, the one we just had and this one, I'm going to know that AF is congruent to FB and CG is congruent to GD, because this right here is both of those put together. This is a right angle bisecting, and because it's the same distance, all the segments are the same. Those are two huge, huge things, and you're going to use them multiple times on the homework. You'll be using them multiple times throughout. So make sure you get a firm grasp of those, and you're just looking out for 90-degree symbols, and you're looking out for these distances being the same. Let's go ahead and put those together in, I don't think I put anything else now. Let's go ahead and put these together in some examples, because sometimes that makes a little more sense. Oh, that's what happened. My whole slide thing is all messed up. That's why I didn't have the other one. I got the wrong thing up. Yeah, we'll find it. We will find it. It's right here. Okay, this says, in the picture below, DE is congruent to JK. It's hard to put a congruent symbol on here, so sometimes you just got to keep it in your head. Keep it in your head that DE is congruent to JK. Because what I'm going to do right now is I'm going to look here. Do we see this 90-degree symbol? Yeah. And it goes to the center. If it's going to the center and it is 90-degree 90-degree symbol here, what do I know about DY and YE? Yes, Rena.
They're congruent.
They're congruent, right? So I know because of this 90-degree symbol that DY is congruent to YE. This 90-degree segment says that JZ is congruent to ZK. So just hold on. Don't write these down. But I know that DY is congruent to YE, and I also know that JZ is congruent to ZK. We can refine that even further. Let's go back to what this said. This said DE was congruent to JK. So if these two are congruent, that means, in fact, all four of those segments are congruent. All four of those segments are congruent. So because DE is congruent to JK, we know, because of this, we know that DY is congruent to YE, which is congruent to JZ, which is congruent to ZK. That's a lot of information just from one little statement. All right, the next thing says that J to K is 30. So J all the way to K is 30, but we know that we have a bisector there, so this is 15, this is 15, this is 15, and this is also 15. All right, then it says that Jx equals 17. So I know J to X equals 17. What is X to Y? What is X to Y?
The S and S2, like hypotenuse equals S2.
That would be if we had 60 degrees.
I'm sure we don't.
Yeah, we don't have 60 degrees. We don't have 60 degrees. But what we do have is we do have a triangle. We do have a triangle. Let's bring that triangle out. We have a triangle J, Z, X, where I have 90 degrees. My hypotenuse is 17, and this is 15. We just need to find that. What was that? It actually is a Pythagorean triple.
That we're supposed to be using that?
You can. Does anyone know the Pythagorean triple for this? Yeah. It would be 8. This would actually be an 8, 15, 17 triangle. If you didn't remember your Pythagorean triples, you can just go x squared plus 15 squared equals 17 squared. 17 squared I'm always rough on for some reason. All right, so you'd have x squared plus 225 equals 289, and you end up with x squared equals 64, which is the same thing as Grace said, x equals 8. So this length right here is 8, which means this is 8. Yeah, Grace.
Oh, I got this all through those.
Oh, cool. Cool. And we're supposed to find, what is x to y then? Akshay,
8,
why is it 8?
because xy equals like the distance of xc,
Why?
because the thing above it says like two chords are congruent if and only they're equidistant from the center.
Yes, and are both our chords equal to each other?
Yeah.
Both of our chords are equal to each other. So they must be equidistant from here. So that means this 8 that we just put down is the same distance as y to x. So yx is equal to 8. So we actually use both of them in this. Yes?
Rather than doing it like that and transverting the triangle, can you just do like another dashed line from the D to the X, and then use that triangle? Because you can assume that the dx is also 17. Then you're just solving for x, y, straight away.
Don't. You're 100% right.
Okay.
You're 100% right, and it all works out. We just don't happen to have a theorem that says that this length is the same. It is. It absolutely. You're not going to get anything wrong. I'm not going to take any points off for it. But as our notes go, and as me teaching you what the theorems mean, no, you can't. You're going to get the right answer. All right. Just always make sure that all the stuff matches. All right. Don't assume these two things are equal because you first have to prove that these two chords are congruent. All right. Our next one, it says in circle C, chord AB is 12 centimeters from C if the radius of, I think that's circle C. Can I take a picture of yours real quick? If you didn't, mine doesn't translate the words as well. Thank you very much. That way I have all the proper lingo that we have on here. All right, in circle C, chord AB is 12 centimeters from C. If the radius of C is 18 centimeters, what is the chord length? So first of all, let's make a circle. Let's make a circle C. So I got a circle here. I got a big old C in the center. All right, now we need to have a chord, and we're going to call it AB. And it's 12 centimeters away from C. So we just have to make some chord. We know it's not a diameter, so let's just put it anywhere. Let's put it right here. And I call that A, B. And then it says the distance between these two things, I'm gonna do a full radius here. But the distance between these two is going to be 12. But then it says the radius of OC equals 18. So I'm going to put another line real quick. And let's not for now. Let's leave it right there. So we have a 12 right there. Our radius equals, how do I want to put this? Our radius is 18, correct? So what would this little distance be right here? Evan, it'd be 6. So we have 12, 6. And it says, what is the length of chord AB? So we're going to go ahead and use a triangle. And this is kind of the key to these problems. You are going to, yeah.
Can't we say that, like, more like it's 90 degrees?
Mm-hmm. This is definitely 90 degrees, right? Because it's a
Or
distance.
it's 90 degrees, let's just say that's like point like, D. Can we say that, like...
So we're going to call that point D.
Yeah, ACD isn't that the same thing as AD? Because doesn't it?
We don't know that. No, that is not true.
Isn't it because it?
Nope. We don't have a theorem that says both those things are the same. But what we can do is we can create a right triangle. We can create a right triangle. What is the length of that purple line I just drew? It's going to be 18 because it's also a radius, right? So this right here is a radius. But this right here is the radius. And this is probably the most missed situation on homeworks and on tests, is recognizing that every one of these that goes to the center is 18. So when I create this triangle, I now have a 12 and an 18, and it's a right triangle. So let's pull out that triangle. Let's pull out that triangle. It is 12. This is 18. We call that D. We call this A. We are looking for that X. So we are going to have 12 squared plus X squared equals 18 squared, which is going to be 144 plus X squared equals 324. Now I'm going to subtract 144 from both sides. And we're going to have X squared equals, make sure I got everything right, 180. Now I got to take the square root of both sides, so you're going to have X equals the square root of 180, but that is not fully simplified. What is 180? Square root of 180 simplified. In other words, what perfect square goes into it? Yeah. All right, so a lot of these are breaking things down into a right triangle and then solving that right triangle. Yes, Amber. Oh, sorry. You were just twiddling your pen. Okay, questions for me? Questions on the homework that was due today? Yes. Yeah. We're okay on the homework then? This one's going to be a little more challenging. Yes? Yeah, you're going to have to tell it to me because I can't find mine.
Name of chord and the arc is subtens. Use the context clues.
So subtens is just what does it arc does it can I take a picture of it real quick? So it says name a chord and the arc it's subtends. So we just pick an arc, maybe AF. It would subtend the arc either AF or ACF.
So
It's just whatever arc it makes.
that's it.
Yep, just like how like an angle like FDC could make arc FC or FAC, same thing. Does that make sense then?
Yeah.
Yeah. That's all I mean by subtend. What does it create? What arc can you create using those 2 points? Other questions? All right, the rest of the class will be yours to finish working. That's about 15 minutes. It should be a good start. Try as hard as you can, especially if you are in the musical, because some of these are a little more difficult. That way you can ask questions.